Oh, no. Oh, it's the same one.
Yeah, we did a lot of 3.5. Let's recap a little bit. All right, in the past, here, I'm going to stand up in the front so I can command your attention. In the past, in like 3.1, 3.2, really specifically in 3.2, we said this. If lines are parallel, then angles are congruent. And you guys just took a quiz on that in 3.1, 3.2, right? And the premise was, again, if you knew that lines were parallel, then you could say that angles were congruent, okay? We're flipping that in 3.5, and we're saying, okay, if I know these angles are congruent, then I can say that these lines are parallel to each other. So it's the converse of that statement, okay? So we're flipping the if and the then statement, okay? So we did these, right? We talked about like how does, we did some of these problems at first where we just found slope using, y2 minus y1 over x2 minus x1, or rise over run. I told you guys about all these theorems on this slide. And remember I gave you an abbreviation for each one? Like in this picture, if I saw that my corresponding angles, like 2 and 6, were congruent, then I could say that line L is parallel to line M. So then my abbreviation for that was corresponding angles congruent implies parallel lines. And then there was one for each one of your angle types. So was that charged, by the way, Brio? The portable charger? Womp womp. It may be dead. Very well could be. It is dead. It is deceased. Yes, sorry. I meant to charge it this weekend, but then I didn't. All right, so anyway, we had an abbreviation for each one of our types of angles. So there's one for corresponding, there's one for alternate interior, there's one for alternate exterior, and there's one for consecutive interior. Let's talk about the consecutive interior ones. Remember, those were the angles that were supplementary to each other. So if consecutive interior angles are supplementary, that implies that lines are parallel to each other, okay? All right, so then we did some examples with those. And the first problems on your worksheet look exactly like this. They'll tell you angles are congruent, and then you have to say which lines are parallel and by what postulate or what converse you can prove them parallel, okay? So you'd say like corresponding angles congruent imply parallel lines. So we did that. We did these problems, which were really nice because we just solved for x, and you guys were really, really good at that. And then this is how we ended the lecture, and we said, okay, if those angles are congruent, then I can say that lines are parallel because they're corresponding. And then for 9, it was a little different because we had alternate interior angles being supplementary, and that's not what we want. So we said, no, those lines are not parallel to each other. Okay. Fast forward to what I'm teaching you today. In any plane, if two lines are perpendicular to the same line, then those two lines are parallel to each other, okay? So if I have these two lines, line M and line N, and they're both parallel, or perpendicular rather, to line T or whatever, then that means that M and N have to be parallel to each other, okay? So two lines perpendicular to the same line are then going to be parallel. So our abbreviation for that is as follows. Two lines perpendicular to same line imply parallel lines. Not much of an abbreviation. Carter, you with me?
No, I am.
Okay, that's all right. Sometimes I got to snap you back to reality a little bit. Carter, this is what we said. I said if I have two lines that are perpendicular to the same line, so like M is perpendicular to T and N is perpendicular to T, that means both M and N have to be parallel to each other.
All right.
So then I just gave an abbreviation for that. Okay. All right. Now, I know you guys have spent all weekend thinking about this. You were really bummed out on Friday that we didn't do any proofs in class. So I thought I would save it for Monday.
Wait, is this going to be on the test?
It's possible. Now, we got bummed out about proofs in the past because it was new, but honestly, you guys are so well equipped to handle proofs now. You guys are little proof champions. You can do it. Okay, so it says given R is parallel to S, so given that those two lines are parallel to each other, and that angle 5 is congruent to angle 6, we want to prove that line L is parallel to line M. Bless you. You'll find that the proofs in this section are shorter than before. This one is less short, but the next proof we do, super short. We start the same way, though. Let's do our statements and reasons. Statements, reasons. All right, so R parallel to S and angle 5. This should be congruent to angle 6, so I snuck a little congruent symbol up there. And that is given. All right. Let's see what we can get from that. So I know R is parallel to S. So this line is parallel to that line. So these guys are parallel. I want to show the other two lines are parallel. So I want to show that L is parallel to M. Okay? In order to do that, that means I have to get one angle on L to have some sort of relationship to an angle on M. Now, they tell me that 5 and 6 are congruent to each other. So that's great, but like those aren't connected by the same transversal, so I can't get an angle pair out of those straight away. Now, imagine this. I'm telling you right now, you have to compare one angle to another angle in that picture. I have just those 4 angles. Those are the only ones we're going to use. The picture's set up for me to use what type of angles, do you think? Not vertical. Because I don't have like any of the angles that are vertical to each other. For sure. Consecutive interior. I have a bunch of interior angles and it's all like next to each other by connected on the same line. So Oliver's right. I'm going to use consecutive interior angles at some point. Okay. Now, which consecutive interior angles should I start with?
6 and 7.
I could, you know what? Fine. Let's do it. Angle 6 is an angle 7. Okay, so what do I know about 6, 7?
Linear.
Not exactly. They're what?
Supplementary.
Okay, so let's say that angle 6, let's do it this way. Measure of angle 6 plus the measure of angle 7 equals 180. It's actually a shortcut. I should have did another step before this, but that's okay. We're going to be lenient on this. Okay. How can I say that? What type of angles were they? Not linear.
Supplementary angles.
Yeah, let's say consecutive interior angles theorem. Could put THM. Because if we know that lines are parallel, then we can say consecutive interior angles are supplementary. Okay? All right, so that was angle 6 and angle 7. But what do I know about angle 5 and angle 6?
They're equal.
Yes. So what could I instead say? 5 and 7 equal 180. Now, before I do that, I'm going to say this. Measure of angle 5 is equal to the measure of angle 6. What should I justify that with before I launch into what Oliver said? You guys remember what that is? It's based off our given. 5 is congruent to 6, and then saying...
Definition of congruent angles.
Yes. So definition of congruent angles. Good. And then let's do what Oliver said, which was measure of angle 5 plus measure of angle 7 equals 180. And I can do that because I know that 5 and 6 are equal to each other. So that would be what property? Very good. Prop. All right. If I know that 5 plus 7 add up to equal 180, then what can I say?
4 and 5 do the same thing.
Yeah, I don't have to say that, though. They do, you're right, but I don't have to say that. What does it get us if I know that 5 and 7 add up to 180? What is our goal?
Oh, that they're parallel.
That they're and I can now say that because I know that these angles are supplementary to each other. And what does it mean if those consecutive interior angles are supplementary? That implies that lines are parallel. So then I can go ahead and say that L is parallel to M, and then my reason for that would be consecutive interior angles supplementary implies parallel lines.
You just made that
Yeah,
up.
you're just making this up.
So if I go back to postulates and theorems, we have an abbreviation that says exactly that. Consecutive interior angles supplementary implies parallel lines. So we learned it on Friday, but you guys haven't done it all weekend. So it's been a minute since you've seen it.
It's pretty long.
Yeah. Yeah. I could have stated more. I could have added more steps in here. I could have worked with supplementary and such, but I kind of did like a shortened version of it. Okay. But again, if I like try to recap this with like a picture, I started by saying, okay, I know that angle 6, since that these lines are parallel to each other, I know that 6 and 7 would be supplementary to each other. However, I know that angle 5 and angle 6 are the same, so that means 5 and 7 would be supplementary to each other. But if 5 and 7 are supplementary to each other, then these lines would be parallel, because we have a postulate that says that. So that's how that proof is, okay? All right, one more proof. This one's shorter. What color should we make it? Hot pink. Is that hot pink enough?
Oh, yeah.
This is good. It's about as hot as it gets. All right. Statements and reasons. Angle 2 congruent to angle 1, comma, angle 1 congruent to angle 3. Reason is given. Let's mark that in my picture. Angle 1 is congruent to angle 2, but I know that angle 1 is congruent to angle 3. Shoot, man, even before I go any further, I can say something on like right away. What can I say?
Angle 2.
Yeah, 2 and 3 have to be the same, right? Because I know 2 is the same as 1, but 1's the same as 3. So then let's just say that angle 2 is congruent to angle 3. I need a reason. Good. Substitution would have worked, but Raph is right. Transitive property is better here. Because the 1 was repeated straight away. All right, super. I know 2 is congruent to 3. Hey, what's my goal? I want to prove that ST is parallel to YZ. So I need to show that an angle on one of those lines is congruent to an angle on the other one of those lines. Did I do that already? I did. I have this transversal that connects them, right? And if I lasso this and throw it off to the side, what type of angles do I have there?
Wait, oh my gosh. Wait, how do you select it? Like, how do you, like, circle it?
So you go to your options here, right? You see
Yeah.
this one right here? The one to the right, the like striped?
Yeah.
If you draw a circle around it and then release and then use your finger, you can just drag it all around, man.
Doesn't
Pew.
fucking work. No,
Does-
it actually doesn't. Okay,
You good?
maybe.
Anyway, what type of angles are those? Alternate interior angles.
How did you get the parallel line?
How did I get the parallel lines?
Did you just trace it?
Well, that's what I'm trying to. Oh, you mean these?
Yeah.
Like the picture here? I traced it in here, and then, so I did this, and this, and this, and then I knew that these were parallel. And then Raph was asking the same question. I selected to this guy right here, this striped pen, and then you just draw a circle around it, and then you move it
I
around.
thought you select it like you got the picture.
Oh, no.
You can't do that.
Yeah. Okay, so alternate interior angles are what I have. That's enough to prove that the lines are parallel because I knew those alternate interior angles were congruent. So then I can just say ST parallel to YZ And then you guys told me it was because of alternate interior angles, so we would say alternate interior angles congruent imply parallel lines. It's a long one. That's the abbreviation.
I don't think we should abbreviate it.
I'm going to be honest, in the past, when I've taught this,
How are we gonna memorize it?
Yeah, that's true. Can we get a
flashcards, studying, I don't know, you're capable. You guys are capable of some things.
Yeah, they banned Quizlet.
Again?
What do you mean again?
It's been banned. No, it's, okay.
That is just not true.
How would Quizlet help you in a situation like this?
You get the
You should show
flashcards?
flashcards.
Oh.
Like, I can't afford the paper.
Oh, I got some for you. Don't worry about it, pal.
Alright.
You got flashcard paper. No worries.
Can't afford to draft like.
All right. There's our other proof. That's what I got. Any questions? Super. Let me give you your worksheet.